All right, today's learning target. I can apply my knowledge of prime and composite numbers and the divisibility rules for 2, 5, and 3 so that I can identify most prime and composite numbers from 1 to 100. I can divide the remaining numbers from 1 to 100 by 7 so I can determine if the rest are prime or composite. I will know I've got it when I've accurately identified all prime and composite numbers from 1 to 100 on the chart. Let's begin by defining what prime and composite numbers are, since we have to identify those on the chart. A prime number can have exactly 2 whole number factors, one and itself. So when we break numbers down, or we call that factoring, we're looking to see how many whole numbers can divide evenly into 7. And if there are exactly 2, no less than 2, no more than 2, then that number is considered prime. So when you look at the number 7, there are only 2 whole numbers that can be divide evenly into 7. When we break 7 down into whole numbers factors, the only 2 we can find are 1 and 7, 1 and itself. 23 is another example of a prime number, because when you look at the whole number factors for 23 and you break that number down, the only 2 you'll find are 1 and 23, 1 in itself. So again, prime numbers are numbers that are broken down into exactly 2 factors, 1 in itself. They have no more or no less, exactly 2. A composite number is a number that can be broken down into 3 or more factors. 3 or more factors, composite. So if we look at the number 12, we can see that we were able to find 1 and 12, 1 in itself, but there were others as well. 2 and 6 are whole numbers that go evenly into 12, so they are factors of 12. And 3 and 4 divide evenly into 12. So it has actually 6 total factors, 3 factor pairs that make 12. Therefore, 12 is considered a composite number. It's composed of many different factors. And then finally, 9 is another example of a composite number. This composite number 9, we can see, has 3 factors. It's got 1 and 9 and 3. Remember, when we have 3 times itself and we repeat a factor, we only count that factor once. That's why we have 3 here for 9. So both of these fit the definition. 12 and 9 each have 3 or more factors, so they are considered a composite number. Remember, the number 1 is not considered prime or composite, and that's because it only has 1 factor itself. Remember, we factor or break down 1 by a whole number. The only one we got that goes into 1 is itself. It's 1 times 1. It repeats. We don't count it twice. It has 1 factor, just itself. And that is why it is neither prime nor composite. Now we're going to go on to the chart, and we are going to be using color coding to identify which of those numbers from 1 to 100 are prime, which numbers are composite, and marking 1 as neither. So this is where it would be good to have a highlighter or colored pencils in an orangey or yellow color, blue, and pink. We're going to highlight or color the boxes of numbers that are neither prime nor composite, all the composite in blue, and all the prime in pink. We're going to start with the number 1 because we just talked how 1 doesn't fit the definition of prime or composite. So it's neither prime nor composite. So we're just going to mark that off in this orangey yellow color. Just going to color in that box. And now we're going to go in a systematic way to identify the rest of these, whether they're prime or composite. And we're going to use some divisibility rules here. We're going to start with the number 2. The number 2 is prime because it only has two factors. It only has 1 and 2. Those are the only two whole numbers that divide evenly into the number 2. All right, now we are going to be using those divisibility rules to try to quickly identify all the different primes on here and all the composite numbers on this chart from 1 to 100. All right, we just got that 2 as prime, and what we also know from our divisibility rules is 2 has a special rule, and 2 goes into other numbers evenly as long as those numbers are even numbers. So even numbers are numbers that end in either a 0, a 2, a 4, a 6, or an 8. If the ending or last digit of a number is 0, 2, 4, 6, or 8, then we can identify that number as an even number. And if it is an even number, we know you can split that number equally in half with no remainders or leftover pieces. So that means 2 is automatically a factor of all even numbers. So that means that those numbers that are even numbers land in the composite category because even numbers have 1 in itself as 2 factors, and then 2 would automatically be a third factor, which would throw that number into the composite category. Remember, composite numbers have at least 3 factors. 2 is the only even prime number. So the rest of those numbers on your chart that are even are going to be highlighted in blue to identify them as composite. So if you look, 2, right underneath the number 2 in the chart are all other numbers that end in the digit 2. And so 2 is a factor of all those. And if we go over across the first row, 4 is an even number. It has 1 and 4 as its factors, and the number 2 is also a factor. And any number that ends in 4 has 2 as a factor as well. So that whole column of even numbers are considered composite because they have 1 in itself and 2 as a factor. Then we hop over to 6, that's an even number, and so are all the numbers below it because they end in the digit 6. All of those numbers are divisible by 1 in themselves and the number 2. And then we can go over to 8. 8 is an even number divisible by 1 itself and 2. And all the numbers beneath it end in 8, so they are also divisible by 1 itself and the number 2, making them composite. And finally, any number ending in the digit 0 is also divisible by 2, 1 itself and 2. So all those numbers in that column are even, and 2 will go into them, making that the third factor for it and making them composite. Okay, the next one we're going to check is 5. We're going to skip over to 5. 5 has a special divisibility rule. 5 says, hey, if your number ends in a 5 or a 0, then 5 is automatically a factor of it. But before we start identifying numbers that 5 goes into evenly, we're going to note that 5 itself is prime. It only has 2 factors that go evenly into 5, and it's 1 in itself, so that lands it in that prime category. But then we look for the other numbers that 5 goes into evenly. Those are numbers that end in 0 and 5. Such as 15, 25, 35, 45, 55, 65, 75, 85, and 95. All of those are composite numbers because they have 5 as a factor. They end in 5, therefore 5 will go into them evenly. So they have 1 itself and 5 in their list of factors, lumping them into that composite category. We can also check the digits for the ending digit for 0 because 5 will go into all those numbers evenly. But as you can see, we've already highlighted those because not only will 5 go into them evenly, but they are also even numbers, and therefore 2 is also a factor. So every number in this column has 1 in itself, a 2, a 5, and other factors that are going to them, but we just need to be able to categorize them as composite by finding 3 factors, a minimum of 3. The next one we're going to check is 3. 3 also has a divisibility rule, so rather than trying to go and try to divide all these numbers by 3, we can just run the divisibility rule check for 3. First of all, 3 itself is prime because it only has 2 factors, 1 in itself, 2 whole number factors. So we'll color that pink for prime. And then what we're going to do is we're going to go through and use the divisibility rule for 3 by identifying, remember the rules, divisibility rule for 3 is the sum of the digits that you're given. If they are divisible by 3, then the number itself is divisible by 3. Well, 7 is a number by itself. Basic fact knowledge tells you that 3 does not go into 7 evenly, so we're going to leave it alone. We're not going to color it in blue or pink at this time. We're also going to check 9. Your basic fact knowledge should tell you that 3 goes into 9 3 times. So 3 is a factor of 9, and so is 1 and 9. So we are going to categorize that as a composite number. It has 1, 3, and 9. It has exactly 3 factors. Then we're going to come over to 11, and this is where I want you to write the sum in the corners. We have 2 digits, so we're going to apply that sum rule. The divisibility rule for 3 says add the 2 digits together, and when you add those 2 digits together, you get 2. 1 plus 1 is 2. Just going to select a smaller pen here. So we're going to write the sum of the digits lightly small in the corner up there. And then and we know that 3 does not go into 2 evenly, so we're going to leave it alone. Now we're going to check 13. Basic fact knowledge should tell you no, it doesn't. You're supposed to know your facts from 3 to 1 to 12. So 3 times 1, 3 times 2, 3 times 3. So looking at 13, your basic fact knowledge should say no, 3 doesn't go into it. But if we use a divisibility rule check just to practice it, 1 plus 3 is 4, and 3 will not go into 4 evenly, so we're going to leave that alone. We come up to 17, and your basic fact knowledge should be telling you no, but let's apply the rule. Add 1 and 7 together, you get 8, and you check. Does 3 go into the sum 8 evenly? No. Therefore, 3 will not go into 17 evenly. We're going to leave it alone. 1 plus 9 is 10. 3 does not go into 10 evenly. Therefore, 3 will not go into 19 evenly. We're going to leave it alone. Okay, we're going to do one more row, just applying that divisibility rule. But again, we're still in a row where you should know just by looking at the number whether or not 3 is a factor. All right, 21, 2 plus 1 is 3. And 3 does go into 21. So that's actually going to be considered a composite number because 1 and 21 work, and 3 is that third one we're looking for to prove whether it's composite or prime. So we are going to shade that one in blue as composite. Then we'll do the next one, 23, 2 plus 3 is 5. And 3 does not go into 5 evenly, so we're going to leave it alone. Then we do 27. 2 plus 7 is 9. And 3 goes into 9 evenly. Therefore, 3 will go into 27 evenly. There is our third factor, throwing that into the composite category. Color that one blue. And finally, in the last one in this row, we have 2 plus 9 is 11. And 3 does not go into 11 evenly, so we're going to leave that alone. All right, what I want you to do for the rest of the numbers here from row 4 all the way down to the bottom, all the numbers that are still not colored, they're white, I want you to add the digits together and put the sums in the upper right corner for those numbers. And then turn your video back on to see if you got the sums correct. Once you have the sums correct, we are then going to go through and color the composite ones. So pause the video and find the sums for those remaining rows. Okay, now that you have your sums in place, the next step is going to be to go through those sums, if you haven't already, and shade in the sums that are divisible by 3. What numbers in the corner will 3 go into evenly? If they go into that sum evenly, then you know they go into that number in the box evenly. Okay, for example, 3 does not go into 4 evenly, so we're going to leave it alone. 3 will not go into 31 evenly. The next box, 3, will go into 6 evenly. Therefore, automatically we know without dividing that 3 will go into 33 evenly. So you should color that box blue because 3 is a factor. 1, 33, and 3 are the factors, 3 factors that would throw it into that composite category. So go through the rest, and when you're done going through the rest of those rows and shading blue for the ones that 3 will work for, turn the video back on to make sure you didn't miss any or that you didn't highlight something you shouldn't have. So pause the video, finish your divisibility for 3, color in composite numbers in blue, and then turn the video back on to check yourself. Okay, so just checking out this row here. Again, we had a 6 for 33, so that you should have shaded in. The 39 should be shaded in that row. And then if you go down to the next row, it should have nothing added to that. We didn't shade anything in that row because none of those numbers that were left were divisible by 3. And then in the next row, 51 is divisible by 3, so you should have shaded that. And you should have shaded 57 because that's also divisible by 3. And then in the next row, left 61 alone, but you should have shaded 63. Left 67 alone and shaded 69. And then in the next row, you should have left all of those white ones alone. 3 doesn't go into any of those sums, so 3 does not go into any of those numbers. Second to last row, 81, you should have shaded that in blue, and 87 should be shaded in blue. And in the final row, you should have shaded 93 and 99. So that should get us through the 3s. Now we have numbers we still have to check on the chart to see if there's any factor that goes into those other than 1 in themselves. So what we're going to use next is 7. We don't have a divisibility rule, a shortcut for 7. So the recommendation I'm going to make is, hey, we have numbers from 1 to 100. We're going to use our basic fact knowledge to get through these. So when you're thinking about 7, on the bottom here, we're going to just do the Skippy count, the multiples of 7 across the bottom of the screen and on your paper. And then we're going to use those that list to run through the rest of those numbers that are left in white. If 7 is a factor of any of those, then we can color those into the blue category as composite. If 7 is not, guess what? They're automatically prime. We've run all the checks we need to check. 7 is our last one to get any composites that are left in this chart. The rest will be prime when we're done with 7. So to Skippy count by 7, we go 7. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, 7 times 5, is 35, 7 times 6 is 42, 7 times 7 is 49, 7 times 8 is 56, 7 times 9 is 63, 7 times 10 is 70, and 7 times 11 is 77, 7 times 12 is 84, 7 times 13 is 91, and 7 times 14 is 98. So I wanted to get all the way through to as close to 100 as I can without going over, and that would end my list. Because if I do 7 times 15, I'm going to land at 105, and our chart only goes up to 100. And we're only responsible to identify all prime and composite numbers through 100 in our standards. So we're going to use this to go through and eliminate any numbers that are still left on our chart. So first, 7. 7 is prime. It only has 2 factors, 1 and itself. Whoops, didn't mean to turn that color. 7 is prime. So we're going to go up and we are going to shade that box pink. Alrighty, and then we're going to go through, and anything that 7 is not in our list as a multiple of 7 automatically turns pink. So I'm going to look at the rest of this list. 11 is not in my list. It's 7, 14, 21, 28. So just going through this row here, not in the list is 11. 7 doesn't go into 11. 7 is not a factor of 13. 7 is not a factor of 17. And 7 is not a factor of 19. So I can automatically categorize those now as prime. I've exhausted all possible other factors for those. 7 is my last one. Well, 7 doesn't go into 23, it's 21 and then 28. And then from 28, it jumps to 35, so it doesn't go into 29 either. Or 31, because it goes from 28 to 35, 35 to 42, so 37 isn't a multiple, so 7's not a factor. 41 is not a factor. 43, sorry, is not a multiple of 7. 7 won't go into 41 or 43. 7 doesn't go into 47 evenly. It does go into 49, so I'm going to leave that alone for now, and I'll come back. Any that's left will be considered composite. So I'm at 49. The next one is 56, so I can shade all those that run up to 56 that are still white and pink. That would be 53. Then it jumps from 56 to 63. So 59 is not going to be composite, neither is 61. Then I'm at 63 here, and I'm going to jump to 70. So 63 to 70. Nothing, anything in between 63 and 70 should be shaded pink. It's prime. So I'm at 70 to 77. That means 71, 73, 77 is in my list. That means 7 is a factor. So 7 will go into 77, so will 1 and 77. Now that I found a third factor, automatically composite, I'll come back and get it in a bit. Now we're looking for numbers between 77 and 84. 79 and 83 run between those. 7 is not a factor of either of those, automatically prime. Now I'm at 84 to 91. Well, 89 falls in between, and that makes that number prime. And then when I look at 91, it's in my list. That's one we might not recognize. It's 7 times 13. So I'm going to leave that blue. It's composite. And then 97 is not in my list, so I'm going to shade that. All right. I did miss one here. 7. Oh, yeah, I didn't miss it. Sorry. I need to shade, I was thinking 77 for a second. Should be blue. Of course it should be blue. All right, so this one right here, 49, 7 is a factor, so is 1 and 49, 3 factors, composite. 77 has at least 3 factors, 1 and 77 and 7. And then 91 has 1 and 91 and 7. So at least 3 factors. Now we've done it. We have shaded our chart. And found all the primes and all the composite numbers between 1 and 100. I just want to point out some that are widely missed. A lot of students make the mistake thinking that 51 and 91 are prime. So a lot of times we get confused on those two for sure. I see students make that mistake a lot, so I want to point it out. Even 57, okay? Those numbers that are divisible by 7 and 3 sometimes get missed. So just be on the lookout for some of those and run your divisibility check. You don't have to long divide. It can be a quicker check if you know those divisibility rules and you know how to use them. All right, so identifying the prime numbers from 1 to 100 was the lesson objective today, and we have now done that with the chart, and we've also practiced and applied those divisibility rules to do so. So this concludes the notes on the prime and composite chart.